So we discussed about recurrence relations and how this recurrence relation is found. We have just seen, like you have a size of problem n, that's n size problem will be divided into a smaller problem of size n by b, and a stands for total number of sub problems of the size, and this Cn is locally computed time required to divide the n size problem into n by b size problem. So let's see some of the recurrence relation for recursions, like when we have said recurrence relations, and as I said, any algorithm or any problem, if you write it in terms of recursion, then you can form a recurrence relation. So let's have this factorial equation, or the equation which we have used for like the code which we have written, or the algorithm which we have discussed for a factorial. This algorithm I have just taken here, and this technique of factorial is technique of writing recursion for factorial is also called as decrease and conquer. So what we are doing is, we have a problem of size n, and each iteration, if it is a base case, like where n is equal to 0, then it is returning value 1, and if it is not a base case, every time we are reducing the problem by size n minus 1. So as per our recursion general equation, what we have, t of a, then t of n by b, t of n equal to a into t of n by b plus cn. So now let's see, t of n will be as it is for us. Now the problem of size n, we are dividing each time to n minus 1, so we are decreasing it. So our equation here will be n minus 1, not n by b in this case, okay, because we are just dividing it to size 1. Now how many sub problems every time we are making? You can see that only one sub problem we are making. So that is why a is equal to 1 here. And how much time it is needed for the size like n to decrease by 1? Just some constant time. Like if I write 1 also is fine, but we will write some constant c. So if someone tells you that a recurrence relation is like this, then this is the recurrence relation for this decrease and conquer problem. And how to solve this recurrence relation, I will just explain in further videos, but like just from looking at this code, we have formed a recurrence relation like this. Now let's take one more recurrence relation. I have just randomly written this, like I have given the name to add, and what we are doing is, like if n is less than or equal to 0, we are just not considering it. But if n is greater than 0, what we are doing is, we are doing n plus, like we are adding it, but what we are doing, we are decreasing the problem n to n by 2. So our equation t of n, again what is the format of our this one, t of n equal to a into t of n by b plus c into n. Okay. So now how much time I need for this problem? You can just look into this problem, that this problem of size n was there. Now I have divided that problem to n by 2. But now in this case, when I am returning in this case that n plus add n by 2, how many n by 2 sub problems I am doing? N is just an integer right here. So if n is just an integer, I have to just divide n by 2, and I have to come back to what is value of n by 2. So I have not dividing into two different sub problems. I am just one single value, we are just taking that. That's why a is not going to be 2 here. We are just taking a is equal to 1 here. Okay, 1 into t of n by 2, and how much time it will need for divide n by 2? This is just a constant time c. So for this code, what we are going to have a recurrence relation is t of n equal to t of n upon 2 plus c. Okay, this is what our problem may look like. But still again this looks like a divide and conquer problem, but we'll just write like this. It's not actually divide and conquer, just we are dividing n by 2. And I will just take one more example for divide and conquer. So let's say I have an array of size n let's say I have this array of size n. Okay, now what divide and conquer do? So array size is n. Now it will just divide this array of two different sizes, like two same sizes, equal sizes I could say. So this is of size n by 2, this array is of size n by 2. Now this another array, next I will go again, this n by 2 size array will be divided to another n by 4 array and another n by 4 array. Same way this n by 4, n by 2 array will be divided to another n by 4 array, and this will be another n upon 4 array. And same process will continue till we remain with one single element in each array. So now what should be our T of n formula here? In general formula, T of n equal to A into T of n upon B plus C into n. Now if you look here, our T of n will be how many sub problems we are dividing. See, one problem was there, that one single problem is divided into two sub problems. So now our A became 2 here. So number of sub problems are 2. And if you look this sub problem, this is again divided into two sub problems. Again this sub problem is divided into two sub problems. So every time we are dividing one problem into two sub problems, again one sub problem into another sub problem. So that's why our A became 2 here. How much size of a sub problem? If your size is n, it is n by 2. If size is n by 2, it is n by 4. So we are actually divided by 2, like size will be n upon 2. Now, how much time do I need to divide an array of size n into two n by 2 size arrays? Anyway, I am going to traverse each and every element and then only I will divide it by 2. That is why I will just take amount of or size of array which is required to make this of size n. And this is one of the sorting algorithm, merge sort algorithm, which you might have studied in data structure. So merge sort has, you are dividing each array by 2 and every time you will go till you reach to the end. So this is the size of your sub problem, this is number of sub problem at each iteration or each recursion, and this n is your time required to divide the size of problem n to n by 2. Now one more question may arise, like at this stage we can understand that each n size problem need time n by 2 and n by 2 to divide it into 2 n by 2 sub problem. But how much, like why n is required at this stage? See, this n by 2 problem will be divided into 2 n by 4 problem. So divide into n by 4 problem, this may need a time of n by 2. And again this n by 2 will be divided into 2 n by 4, so that will need n by 2. So n by 2 plus n by 2 will be total time again is n. So you can see that at each stage we are locally needing a size n or time n to divide that problem into a of size n by 2. Okay, so yeah, next time we'll see, in next videos we'll see how to solve this recurrence relations.